In section 3, we're going to talk about pyramids. And a pyramid is a solid with one base and triangular faces. So similar to a prism, where with two bases and all faces rectangular, because a pyramid only has one base and all of the other points meet at a vertex, the faces are all triangles. And all the pyramids that we are going to be talking about are going to be right pyramids similar to the prisms. So let's talk about a few examples of the type of pyramids we'll be seeing. So the way we name pyramids, same way we name prisms, based on the base shape. So in this first pyramid, we have a square base, so it is a square pyramid. Our second pyramid has a hexagon as a base, so it is a hexagonal pyramid. And then our last pyramid has a triangle as a base, so it is a triangular pyramid. So the base shape determines the name of the pyramid, just like with prisms. So when we find the base area of the pyramid, similar to prisms, we just find the area of the polygonal base. So whatever the base shape is, we find its area using its specific formula. So we're going to take a look at a few examples. So in our first example, we have a square pyramid. So the way you find the area of a square is you do length times width, and because those are both the same, we're going to do 8 times 8, since the length and width of our base is 8 meters, so we're going to get that the area is 64 meters squared. We have another square pyramid in our second example, so the way we find the area is going to be 10 times 10, so that's going to give us an area of 100 inches squared. In our third example, we have a hexagonal pyramid. So the way we find the area of a hexagon is we do 6 times 1/2 base times height. Since we can split that hexagon into 6 triangles with area of 1/2 base times height. So what we need to do is find the height of each of those triangles, which thankfully is given to us. That's what this distance right here is. That's the height of each of our triangles within our hexagon. And we have the base of 5 feet, so the area is going to be 6 times 1/2 times 5 times 4.33. So when we do 6 times 1/2 times 5 times 4.33, we're going to end up with 64.95 feet squared. Next, we're going to talk about the lateral area of a pyramid. So each face of a pyramid is a triangle. So we're going to find the area of the triangular faces. And because each face is a triangle, that means its area is 1/2 base times height, and then we multiply it by the number of faces we have. So the number of faces we have, remember, is based on whatever our base shape is. So in this example, we have a square base, which means there would be 4 faces. So there would be 4 triangles to multiply it by. So let's go ahead and look at our same pyramids and find the lateral area of each. So in order to find the lateral area of a pyramid, its height isn't actually perpendicular. What we want to do is we want to use something that's called the slant height. Which we usually use a lowercase l to represent. So I'm going to go back up here and I'm going to change my formula because we don't have a perpendicular height, we have a slant height. So I'm going to change that to an L. So 1/2 base times our slant height times the number of faces we have. So in this case, our base is a square, so we have 4 faces whose area is 1/2 times our base, which is 8, and then our slant height, which ends up being 6. So we do 4 times 1/2 times 8 times 6. So we get that the area is 96 meters squared. In our second example, we are given our slant height of 13 inches. We still have a square base, so we have 4 faces, so it's 4 times 1/2 times our base of 10 times our slant height of 13. So when we do 4 times 1/2 times 10 times 13, we get an area of 260 inches squared. In our third example, we have our hexagonal pyramid, which has 6 sides, so we have 6 faces, so that's 6 times 1/2 times our base of 5 times our slant height of 10. So when we do 6 times 1/2 times 5 times 10, we get an area of 150 feet squared. Now I want to talk about the total area of a pyramid. So that is going to be the sum of our base area and lateral area. So again, also referred to as surface area. So when we find our surface area, we just add the 2 areas we just found together. So the surface area of our first square pyramid, the base area was 64. And our lateral area was 96, so 64 plus 96 gives us a total surface area of 160 meters squared. In our second square pyramid, we had a base area of 100 and a lateral area of 260, so 100 plus 260 gives us a total surface area of 360 inches squared. In our last pyramid, our hexagonal pyramid, the base area was 64.95 plus our lateral area of 150, which gives us a total surface area of 214.95 feet squared. Lastly, we want to talk about the volume of a pyramid. So the way we find the volume of a pyramid is 1/3 area of the base times the height. So B stands for our base area. And because there is only one base in pyramids, we don't have to do anything special because like we did with the prisms where we only had to account for one base, because there is only one base in a pyramid, so that's the base area we use. So in our examples, when we talk about height here, this is our perpendicular height. So in our first example, our height is going to be our 5 meters. So our volume is going to be 1/3 times our base area, which was 64, times our height, which in this case is 5. So 1/3 times 64 times 5 is going to give us a decimal, so it's approximately 106.67. And then units are cubic, so it's going to be meters cubed. In our second square pyramid, we aren't given the perpendicular height. We know the slant height and we know our base. So similar to what we did with prisms, we have to solve for that height. So the distance from our perpendicular height to our slant height is going to create a right triangle, and that height ends up in the middle of our rectangle, which means this distance is 5, and we know our slant height is 13, so we're going to use the Pythagorean theorem to solve for our height. So our height squared plus 5 squared is going to equal 13 squared. 5 squared is 25, and 13 squared is 169. So once we subtract 25 from both sides, we get that our height squared equals 144. So we take the square root, we get that our height is 12. We can now find the volume of our square pyramid. So we have 1/3 times our base area, which is 100, times our height, which is 12. So when we do 1/3 times 100 times 12, we end up with 400, and their units are inches cubed. In our last example, we have to do the same thing. We aren't given our perpendicular height, but we know our slant height is 10, and we know the distance from the center of our hexagonal base to the sides is 4.33. So we can use that to solve for our height. So our height squared plus the 4.33 squared is going to equal 10 squared. So when we square 4.33, we end up with 18.7489, and then 10 squared is 100. When we subtract the 18.7489, we end up with h squared equals 81.2511, which means that our height is approximately 9.01. So when we go to find our volume, we have 1/3 times our base area, which was 64.95, times our height, which is 9.01. So approximately the volume of our hexagonal pyramid is 195.07 feet cubed. Now, if we were to use more decimal places for our height, we would end up with a more approximate volume. So that's why this is only an approximate volume for our pyramid, is because we had to round in finding our height. So when you're working on the assignment over pyramids, let me know if you have any questions over how to find base area, lateral area, total area, or volume.